Alright, class 11. Today we are going to discuss about addition of vectors. If you haven't checked the previous video, first go and check that video. Alright, then only watch this video. Okay, say for example we have two vectors. I have given the example of two forces in here, one of 2 Newton, the other of 4 Newtons. So these two vectors, as you can see, these two forces are in the same direction. Okay, so what will be the sum? What will be the addition of these two vectors? The sum of these two vectors will simply be 6 Newton. Okay, and this is the vector of 6 Newton. You can see 4 Newton is about this big, 2 Newton is about this big, so 6 Newton has to be this whole. So it's something like that. Okay, so this is 6 Newtons. It's fair and easy. Since two forces are in the same direction, the sum of these two forces will be a bigger force, which is that of 6 Newton in this case. Then we have two forces. Another example is that of two forces, one of 2 Newtons, the other of 4 Newtons, but now they are oppositely directed. So what will be the sum? The sum of these two vectors will be 2 Newton, of course. But what will be the direction? The direction will be this. Okay, it's like a tug of war going between two forces. So whichever is stronger, that particular force is going to win. So that is exactly what is happening. The direction, since 4 Newton is winning and 4 Newton is in this direction, so therefore the direction of the resultant vector will also be the same, since 4 Newton is the winner. Okay, you can understand it this way. Now, so actually, since we are saying sum of these two forces, although they are oppositely directed, so case of subtraction, this is a case of subtraction. When the vectors are in opposite direction, that is a case of subtraction. But of course, we know subtraction and addition are one and the same thing. Another thing, now these two examples are fairly easy. Here the two forces were in the same direction. Here the two forces are in opposite direction. So the magnitude of the resultant force here is 2 Newton. The direction is that of the winner here, which is 4 Newtons. Okay. But what if the case is something like this? We have two vectors inclined at a certain angle. The same two vectors of magnitudes, 2 Newton and 4 Newton respectively, but they're inclined at an angle of 60 degrees. So what will be the case now? Will it be 6 Newton? Will it be 2 Newtons? Will it be 5 Newtons? Will it be 4 Newtons? Okay, what will be the sum be? Now, since in cases of vectors, we cannot, just by looking at the two vectors and the angle of inclination between them, we cannot give the answer. We cannot give the value of the resultant like in these two cases. Okay, so to deal with cases like this is just one example that I'm giving. There are so many other kind of examples. So to deal with cases like this, we have rules for vector addition. Okay, so today I'm only going to explain the rules to you, only the statements. I'm only going to explain the statements of the different rules. Okay, so how do we calculate, by using these rules, how do we calculate the magnitude and direction of of 2 or more vectors? We are going to do that in the next video, but today I'm only going to explain you the statement, okay, for the different rules. So you have to copy this, don't forget. So triangle rule, it says if two vectors can be represented both in magnitude and direction by two sides of a triangle taken in order, then the third side of the triangle in reverse order gives us the resultant both in magnitude and direction. That is the statement for your triangle rule. So you can pause the video and copy the statement. Let me explain you the statement. What it says is, say for example I have a vector which is directed along this direction, some vector A, and this is some vector B. Okay, so now in the previous video I had spoken about something called equal vectors. Okay, equal vectors are vectors having the same magnitude and which are directed in the same direction. So this is vector B. Now listen to me very, very carefully. Keeping the magnitude and the direction of a certain vector, in this case vector B, keeping the magnitude and direction of this vector B fixed, I can move this vector anywhere. So I can take this vector B over here, keeping its magnitude and direction fixed. So magnitude is fixed, direction also is the same, so this is also vector B. So to say this vector and this vector, they are equal vectors. Okay, so in order to get an equal vector, I can move this vector keeping its direction and magnitude fixed. Of course, I can move this vector anywhere in space. Okay, it'll be the same, exactly the same vector. So that is exactly what I've done here. So keeping the magnitude and direction of vector B fixed, I have moved it over here such that the tip or the arrowhead of vector A ends at the end part of vector B, like this. So this is what is called taken in order, as if these two vectors, they are moving in this direction. They are flowing in this direction as if. Okay, so that is what I've done. So I have taken two vectors in such a way that these two vectors, they represent two sides of a triangle. And they are taken in order. Like I already mentioned, taken in order means as if they are flowing in the same direction this way. So I have two vectors, they represent two sides of a triangle, and I have taken them in order. Then the third side of the triangle. So since it's a triangle, it has to have a third side. So then the third side of the triangle, taken in reverse order, meaning these two vectors, they wanted to, as if they were moving in anti-clockwise direction like this. These two vectors, A and B, wanted to move in anti-clockwise direction. Now I have to have a third vector in reverse order, meaning as if this vector, the third vector, wants to move in the clockwise sense. So this would be reverse order. Okay, if I have three vectors taken in order, then I would have something like this. They're flowing in the same direction. They're all moving in the anti-clockwise direction. Okay, but triangle rule tells us I have to have two vectors representing two sides of a triangle, and they are taken in order, as you can see in my picture here. Okay, then the third side of the triangle in reverse order. This is in reverse order now. Okay, this third vector represents the resultant, that is the sum of vector A and vector B, both in magnitude and direction. So the direction of the resultant vector of these two, the resultant of these two vectors inclined at a certain angle, will be this. Its direction is this, and its magnitude will be this much. Okay, this is what triangle rule tells us. Okay, let me again show you the statement. If two vectors can be represented both in magnitude and direction by two sides of a triangle taken in order, don't forget this, what this means, very, very important to understand what taken in order means. Taken in order, then the third side of the triangle in reverse order, keywords these are, in reverse order, gives us the resultant both in magnitude and direction. I hope you have understood the explanation for the statement. Alright, from the next video onwards, we'll look at the calculations. We have to, like I told you in the very first video, we have to do a lot of calculations, mathematics. So prepare yourselves for that. Today I'm only explaining you the statement. Next rule we have is parallelogram rule, something called a parallelogram rule. Now it says, if two vectors can be represented both in magnitude and direction by two adjacent sides of a parallelogram, starting from a point, then the diagonal of the parallelogram drawn from the same point gives us a resultant both in magnitude and direction. So what this law or what this rule tells us is, we have two vectors A and B. These two vectors, I have taken them in such a way that they form two adjacent sides of a triangle. You can see two adjacent sides of a triangle, and they are drawn from a point. Okay, they are drawn from this point. They are starting from this point. Then what this law tells us is, if we have this case, we have two vectors, they are representing two adjacent sides of a parallelogram, and they are starting from a point, then the diagonal of the parallelogram. Okay, now to get the diagonal, we first have to complete a parallelogram. So this is my, I using these dotted lines, I complete my parallelogram. And mind you, if this is vector A, then this, if I take its direction, then this is also vector A. Okay, because the opposite sides of a parallelogram are equal. The opposite sides are parallel and equal, of course. So therefore this vector has the same direction as vector A, and it has the same magnitude, same length. So this is also vector A. Likewise, mind you, if this is vector B, then this is also vector B. Remember that. This is also vector B. Since it has the same direction and it has the same magnitude, so this is also vector B. Remember that. Okay. So once we have two vectors A and B representing two adjacent sides of a triangle, two adjacent sides of a parallelogram, okay, then first thing we do is we complete the parallelogram. Now once we complete the parallelogram, what this rule tells us is, once we have this two vectors starting from a point representing two adjacent sides of a parallelogram, then the diagonal of the parallelogram starting from the same point, remember, we can have any parallelogram has two diagonals. One is this, okay, but which diagonal are we interested in? We are interested in the diagonal which starts from the same point as these two vectors. So the diagonal of the parallelogram starting from the same point gives us the resultant both in magnitude and direction. That is exactly what a parallelogram rule tells us. Okay, so if this is vector A, this is vector B, then R represents the resultant. The resultant vector is A plus B. Oh, and one thing let me tell you. Say for example A has magnitude 5 and B has magnitude 6. Okay, A has magnitude 5 and B has magnitude 6. This, although I have written R is A plus B, vector A plus B, this does not mean that I am simply going to add their magnitudes. So resultant is not 5 plus 6, which is 11. Resultant is not 11, remember. Okay, that would be the case in case of scalar addition. If I was to add 5 and 6, I would of course get 11. That is scalar addition. But this symbol over here, this is not your scalar addition symbol. This is a vector addition. So in vector addition, here 5 plus 6 is not 11, because in that case you need to consider, in case of vectors, you need to also consider their directions. Okay, we will see what will the magnitude of the resultant be. We will see in the next video. Okay, so I only am suggesting over here, by writing R is A plus B, I am only suggesting that this vector is the resultant, is the sum of vector A and vector B. It does not mean that we simply go and add their magnitudes. Remember that. Same in the case of triangle rule also. Same in the case of, where is that paper? Okay. Same in the case of triangle rule also. Here is vector A, here is vector B. Okay, I've written R is A plus B. This does not mean I simply go on add their magnitudes. Remember, this is vector addition. Vector addition is completely different from scalar addition, because we also need to take into consideration the direction. Now what we will see is triangle and parallelogram rules are one and the same. Okay, triangle and parallelogram rules are one and the same. Okay, let me show you in this video itself how. Say for example I block the upper half of the parallelogram, then what do we have? We have a vector A, you know this is vector B. Okay, then what do we have here? We have vector A and vector B forming two sides of a triangle, and they are taken in order. See, this is vector A and this is the direction of vector B. So we have two vectors taken in order, then the third side of the triangle taken in reverse order. This is the direction of the diagonal. Okay, then the third side of the triangle taken in reverse order gives us the resultant both in magnitude and direction. That is the statement for triangle rule. Okay, so we get the triangle rule from the parallelogram rule also. That is why I'm saying triangle and parallelogram rules are the same. Okay, do let me know if you don't understand. You have to let me know. Okay, you can write in the comment section of the video. All right, you can let me know. So far I haven't got a single comment. Okay, but you can write your comments. If you don't understand something somewhere, you can always let me know. Okay, the final rule that we have is something called a polygon rule. This is not very important. Okay, if you actually know triangle and parallelogram rule, which are actually one and the same thing, then it's more than enough actually. Okay, to solve any of the problems that we get to see in vectors, knowing these two rules, parallelogram and triangle, it's more than enough, it is sufficient. Okay, but still we have a third rule, polygon rule. You might get to write the statement for this. So let me explain you this also. If n vectors can be represented both in magnitude and direction by n sides of a n plus 1 sided polygon. Okay, you have n plus 1 sided polygon. N could be anything. Okay, if n is 4, then 4 plus 1 is 5, you get a pentagon. Okay, if n is 6, you get 6 plus 1, which is 7, you get a heptagon. Okay, if n is 5, 5 plus 1 is 6, you get a hexagon, and so on. So if n vectors can be represented both in magnitude and direction, of course, by n sides of n plus 1 sided polygon taken in order, then the n plus 1th side of the polygon in reverse order gives us the resultant both in magnitude and direction. Let me try to explain this. So for convenience, I've taken a heptagon over here. So sorry, not a heptagon, this is a pentagon. Okay, 5 sides. So I have vector A, vector B, vector C, vector D. You can see they are taken in order. They are all moving in the anticlockwise sense. Okay, so I have 5-sided polygon over here. Then so n plus 1 is 5. Okay, so it says if n vectors can be represented, so I have to have 4 vectors. So if 4 vectors, as you can see in my picture A, B, C, D, are represented both in magnitude and direction by 4 sides, if n vectors can be represented both in magnitude and direction by n sides, it says, so in this case, if 4 vectors can be represented by 4 sides of a polygon, then the 5th side, n plus 1th side, then the 5th side in reverse order will give us the resultant. That is what it says. Okay, so R is A plus B plus C plus D. Now you can also see that polygon rule and triangle rule are one and the same. How? Let me show you. Let us look at vectors A and B. Vectors A and B they are taken in order, as you can see. So can I say they form 2 sides of a triangle? Okay, so they form 2 sides of a triangle taken in order. Then the 3rd side of the triangle in reverse order. This is the direction. Okay, so this is, my picture isn't very good. So this is, let me call it R1. R1 is vector A plus B. So this is R1. We have R1. Now see, R1 and vector C. R1 and vector C, again they form 2 sides of a triangle taken in order. Then the 3rd side of the triangle, let me call it R2. R2 is what? R1 plus C. Vector R1, which is A plus B itself. So R2 is R1 plus C. Then again, vector R2 and vector D, they are taken in order. Then the 3rd side of the triangle in reverse order gives us the result. So R is what? Let me write it over here. R is R2 plus D, which is R2 itself is R1 plus C plus D. Now you know R1 is A plus B plus C plus D, of course with the arrow like this. Okay, so polygon rule also is the same as triangle rule. Okay, you can have any sided, you can take any sided polygon, remember. For convenience, like I mentioned, I have taken a pentagon. Okay, so this is about explanation of the different rules for vector addition. Next class, next video, we are going to see the calculations, how we get the magnitude and how we calculate the direction. Okay, we have to check that, so be prepared for that mentally. Okay, thank you.